My name is Tommaso Ghidini and I'm the head of the Materials Technology section here at the European Space Agency.
So my name is Adrian Graham. I'm a metallurgist at the Materials Technology section of the European Space Agency.
Vega is a very successful launcher developed in Europe by the European Space Agency, designed for launching small payloads from 300 to 2,000 kilos into orbits in order to do scientific and Earth observation missions. Vega is launched in French Guiana from the European spaceport in South America and is contained into what we call a mobile gantry. A mobile gantry is a launch tower that is movable on wheels. It weighs 1,000 tons, it's 50 meters tall and moves on a track 80 meters long. It contains all the systems that are necessary to feed the launcher as it is on ground, and once it's not needed anymore, is moved away and the launcher can start. After a few years of usage, the bearings of the mobile gantry got degraded, at a point that some of them failed and they were actually blocking the mobile gantry from moving. Together with industry, it was decided to use different bearings. But still, we had to demonstrate to the launch authority that the proposed solution was successful. And we, the ESA Materials Laboratory, have been asked to prove that. Our biggest challenge was certainly the time pressure. We had to convince the launch authority that our repair solution was successful in order not to put at great risk the next launch of Vega.
So we were asked to develop a new method of proving that the out-of-plane loading applied to the bearings was going to be sustainable by the new bearing system. To do this, we used the Aramis system, which we use for small-scale strain measurement within our mechanical test systems, and applied it to the much larger system of the Vega translation stage. Aramis is a three-dimensional strain measurement system that uses two cameras and some software to take simultaneous pictures of the same surface. Doing this allows us to measure the strain over that surface and how that strain changes. When we apply a mechanical load and we deform a surface, we can see it change. It can also change in temperature. This is one of the things that's very important to us, that as a spacecraft gets hot and cold, then it will expand and contract. And the Aramis system lets us measure how that changes. So we needed to demonstrate to the project that the approach we had was viable. So what we did was use a bicycle. The bicycle I cycled to work on, because it's about the same size as the system they wanted to measure in Kourou. And we used our Aramis system to measure exactly the same properties as we wanted on the wheels in Kourou on the bicycle.
We ran a second proof of concept on site in French Guiana with the Aramis equipment, where we showed that the equipment was really delivering the data that were needed from the launch authority, and then we were able to authorize the final test campaign. A test program was run then over a week in French Guiana, where thanks to the Aramis system we had the unique opportunity to measure the loads on the wheels as the mobile gantry was moving along its tracks.
So the final result was that we had new bearings that would take out-of-plane lateral loads of 40 tons. And we've proved that the maximum out-of-plane loading on the wheels that we studied was 12 tons. So we were well within our margins of safety for the system. Based on our results, the repair strategy was accepted by the launch authority, and that the translation stage would be able to move out of the way prior to launch. And since then, we've had 4 successful launches, and Vega is continuing on well.